In this video, I would like to talk a little bit about secondary axis in ABES geoDes. The main purpose, the most common purpose for those secondary axes is shown here on this arbitrary photograph that I've grabbed off the internet somewhere. And it shows a very typical situation of a urban highway, and we have two bridge structures, independent bridge structures that run in parallel. And most likely what the designers have done here is they've created one main axis that is common for both roadways, and then each individual roadway, one to the left and one to the right, is defined at an offset to that main alignment. In geodes terms, we would create the main axis with all the usual features, and then in addition we would create secondary axes, one to the left and then one to the right, in order to define the position of each of these two carriageways. Other application for secondary axes would be on-ramps and off-ramps, or station areas for railways and others. Switching to ABES geoDes now, I've made a few preparations for this video. I've defined a road alignment that we will use in the following. For this definition, I've used a number of IP points in plan view, a number of IP points in elevation, and I have also placed axis points at 100-meter intervals to provide a little bit of context in the following discussion. The visualization of this axis looks like this in plan view and like this in elevation. Secondary axes are managed in the next tab over here in our alignment or axis input dialog in ABES geoDes. This provides access to this as of yet empty list of secondary axes for our little test project here. And I'm right-clicking and appending our first secondary axis, and I'm calling it roadway 1 for lack of a better name. Down here we have a list of offsets that we can enter, and because I'm going to look at horizontal offsets first, I'm dragging my horizontal visualization up here. It shows in the blue line our main axis, and I'm now adding a line to our offset definitions. Let's say I'm picking station 0, change 0, and I'm picking an offset of 10 meters at that station. And if I accept that, it pops up immediately in our visualization. And as we can see, the blue line is still our main alignment, and the red line is now our first secondary axis. In case we wanted a second roadway, we could simply right-click and add our second roadway here in this list. And same as before, station 0, and use an offset of, let's say, minus 10 meters this time around. And here it is. So with just a few clicks, we have added the red and the green secondary axis to our blue main alignment here in the middle, both at a 10-meter distance to the left and to the right. Let's go back to roadway 1. And you would have noticed that I've only input one offset value at station 0 here. And the program, for lack of more information, has simply taken that offset value of 10 meters and extrapolated over the whole length of our alignment of our axis. Of course, I could make this a little bit more complex, and I could append another row And let's go to station 800 here, and let's increase the offset to 30 meters there. Accept. And what we see here now is the secondary axis starts at a 10-meter offset here at station 0, and it widens linearly all the way to 30 meters here at 800, station 800, along the way. And of course what we could do is we could insert yet another line, and let's say at station 400 we want to keep it to 10 meters. So this now says keep the offset at 10 meters between 0 and 4, and then increase the offset to 30 meters at 800. And to keep our secondary axis continuous, we need to round out this kink at 400, and I'm using a parabolic rounding here with a radius of 200 meters. What that does is shown here. We have a 10-meter offset all the way to 400, and then we have a gradual increase to a 30-meter offset at 800. And to avoid a kink where we start changing the offset, we have input a rounding at around station 400. Let me quickly touch on the chainage calculation here for our secondary axis. There is no issue here along the straight line. The chainage will be 1 meter here on the blue line, would correlate exactly to 1 meter on the red and 1 meter on the green line. But as soon as we enter a curve situation, we have a shorter way here between the P100 and the P200 axis points on the red line on the inside of the curve than we have on the outside. GeoDes deals with this by always calculating the chainage on the main axis in the middle here on the blue line, and then using that chainage to go out and calculate the point with the conjugate chainage on the secondary axis. So the chainage is measured on the main axis and then projected out onto the secondary axis, and inside or outside a curve, 100 meters on the main axis will translate into a little bit more or a little bit less on the secondary axis. And this is reflected also here where we have a widening and so forth. It's always calculated from the main alignment and then projected out onto the secondary alignment, and we have the so-called conjugate chainage on the secondary axis. Also, another comment I would like to make is with regards to transition curves. Here we have a spiral curve running between these 2 points, and by mathematical definition there is no parallel to a spiral. So what GeoDes does is GeoDes calculates the exact location on the main alignment and projects out the so-called parallel on the secondary alignments, no matter where you are on the axis, whether it's a transition curve, whether it's an arc, or whether it's a straight line. I would now like to talk about the skew column here in our secondary axis input dialog. And for this purpose, I will zoom in on the first 100 meters here on our example. And I would like to make the assumption that we have a skew pier here at the start of our axis. Going back to my roadway 1 definition, I can input a 30-degree skew here at this point, and this moves the starting point for the red secondary axis over to reflect that 30-degree skew angle. Now, if we go back to the input dialog, we see that the next input is at 400 meters, and an empty cell here means default, means 0. So what the program will do is it will gradually, linearly smear out this offset here, the 30 degrees at 0, to a 0 degree reflected here at the next point that we've made an input. Maybe that's not what we want to do. Maybe we want the bridge or the pier axis to go back to 0 here at the 100-meter mark. So in order to reflect this, I'm inserting a new row at 100 meters. The offset there is 10 meters, and I'm going back to 0 with my skew angle. And I'm also inputting a radius so the axis remains continuous. If we go back now, what we see is we are starting here with a skew angle of 30 degrees, and we are back to 0 here at the pier 100 mark. And as you can probably see here on the screen already, the 10-meter offset here at the start is measured in the true direction. So the perpendicular offset at this moment here, the way we have defined it, is less than 10 meters. It's 10 meters along the skew direction and not perpendicular. So as we get to this axis here, and as we get back to a 0 skew, the measurement is perpendicular here, and this is why we need a rounding radius to avoid a kink in our secondary axis. What's also noteworthy here is the fact that we've moved this point to the 30-degree skew, and the conjugate calculation, the conjugate chainage or conjugate station, is from this point at the skew angle to this point, and this is station 0 on our secondary axis. Over here we have station 100, and this is station 100 in our secondary axis, and in between there is a transition, there is a linear interpolation. So the station again runs, or the chainage runs, on the blue line, and the conjugate station on the red line is a projection out from the blue line, reflecting inside and outside curves, and also reflecting skew angles that may or may not change between different chainage values. Now there is another feature that I need to point out in this very context here. There is in fact a second way of defining the offset, the secondary axis offset, by using axis parameters. We've used axis parameters in cross sections and in other contexts, and they can also be used here in the context of secondary axis. I've prepared a axis parameter called off h, and the parameter is 0 at station 0, and the parameter is 20 at station 800, and in between I've selected a linear change. So this is a very simple parameter that takes on 0 at station 0 and takes on 20 at station 800, and values in between as you move along the axis. Now if we go back to the secondary axis, we could put a reference to this of h axis parameter here for the plan view. And if we click accept, the program takes account of this axis parameter and adds it to the existing definition. So we could go either this one or the axis parameter or the table below, or we could combine the two as we have here in this case. The program calculates the offset value from the axis parameter and then adds the offset value from the table and then comes up with the resulting offset as we see it here in our diagram. Sometimes it's not practical to show the secondary axis over the full length of the alignment in our project, and sometimes it makes sense to limit the visualization of the secondary axis. And this is what these input fields up here are for. So let's say we want our visualization to start at station 250 and end at station 580. So these will be the limits for just the visualization, and I click on limit, and if I accept that, our axis is only shown within the specified limits in our input dialog. And of course we can do the same for our other axis, and if we want to show that between 0 and 600, we can of course ask for that. Looks a little bit like this. Up to this point, we have only talked about horizontal offsets. Quite frequently, it's necessary to not only have a horizontal offset, but also a vertical offset. In case where the crossfall has to go over, continuously over both roadways or other cases. And if this is required, we have the exact same functions for the vertical direction in terms of offset definition as we've just discussed for the horizontal. The same table that we have for our horizontal offsets, that table here, we can also input something like this for our elevation. For example, I can have a vertical offset station 0 offset 1 meter and station 800 offset -1 meter, and this will then shift the axis to reflect these offsets in the same way as we did in our horizontal definition. Clicking on accept, and then of course going to our vertical elevation view, we see that the green axis and the blue axis run in tandem, but the red axis goes from above to below within the limits that we've defined. And if I switch off the limits again to see the full axis for our roadway number 1, we see the effects. We are starting 1 meter above the main alignment, and we are going to 1 meter below the main alignment in our elevation view. This becomes a very complex three-dimensional line, and the program will handle that exactly according to the specifications that we have made in the secondary axis input tab. Oh, and if we wanted to use axis parameters for the vertical direction, we could do just the same by creating an axis parameters to our liking and using the station offset in elevation, just like we did with our off H here in plan. It's exactly the same function. It's either one or the other, or a combination of the two.